guys, welcome back. Lesson 96 this time. Fun fact, on lesson 95, I accidentally made a slow-mo video, so I was rewatching it, which I'm glad I did, because when I rewatched it, I realized that about halfway through, I start sounding like this. Seriously, it was really funny. But anyway, I fixed it, so it's all good. And this one is not on slow-mo. So we'll go ahead and get started. So in 96, we're talking about functions and graphing. So I went ahead and put, everything up on the board that I'm going to need because there would have been a lot of like drawing happening and everything. So this way I can just kind of plot it and show you. Generally in your book, you'll be given a graph to put your answers on if you're not, like when you're doing your homework and stuff, if you're not, and a lot of times they don't, if you're not doing it in the book, you won't have access to it. On the test, you might. Anyway, so you could just draw it, sketch it out, use graph paper. I love when you guys use graph paper for those because it's a lot easier to work with. And so then with the table, you can make that on your own too. So we're starting out this unit or this lesson by talking about a square. So we're talking about functions. Functions are something that show a relationship. It shows how one variable or one unknown is related to another unknown. Okay, so let's say we're looking at a square and we want to try and figure out a relationship between the sides of a square and the perimeter of a square. Well, let's talk about a square. What do we know about a square? We know that a square has 4 sides, and we know that each of those sides in a square specifically are the same. So for example, if this side is 5, then all the other sides would have to be 5 because they are all the same length, okay? So once we've identified that, we can say, okay, well, I could easily look at this and say 5 plus 5 plus 5 plus 5 because perimeter is the rim around a figure, right? So 5 plus 5 plus 5 plus 5 gives me 20. So the perimeter is 20, which would be correct. But if we wanted to determine a pattern that we know would work every single time, well, 5 being our side length and 20 being our perimeter, what if we tried this with a different size square? What if we went with a square that had the lengths of 2, 2, 2, 2? Okay, well, 2 plus 2 plus 2 plus 2, that's going to give me 8. So 2 gives me 8. So we can look here and we can observe our relationship, okay? If you notice, from 5 to 20, we can multiply by 5 to get to 20. From 2 to 8, we can multiply by 4. Sometimes your relationship will be adding or something instead of multiplying, so you could always try that. You could say, well, 5 plus 15 is 20, but let's see if that's consistent with the second group of data. 2 plus 15 is not 8, so that would not be our rule. But a rule of multiplying by 4 works here. So then we would just be able to say that the perimeter of a square is always 4 times whatever the side length is, okay? And so that just gives us our rule or our function right here. So then using that rule or function, we would be able to set up a table of data. And so really these values could be anything, okay? But if I plugged in, let's say 7, then this one would have to be 28. Now, if I wanted to find the perimeter when the side length is 15, I would multiply 15 times 4, which would give me 60. Okay, so that's how you would generate your table. Once you have a rule, you just apply the rule by doing that to each one of your S values. So in this case, it says 4 times S equals P. So we know that we can just multiply each of our S values, whatever they are, we can come up with them if we want, times 4 to give us our perimeter values. And that's gonna be consistent across the board. Now I'm gonna go ahead and show you in your book, in the examples, it does a little bit more with the tables before it talks about the graphing. I'm gonna go ahead and show you the graphing part right now, and then we'll come back and do a little bit more with the tables, okay? That way we can kind of stick with the same example. So for graphing, you can just take these points and plot them on your graph, okay? So the way to do that is to remember that this is gonna be your x-axis value down here. These are gonna be your y-axis value. So we always start with the x, so 5 and 20, we would count over 5. So 1, 2, 3, 4, 5. Then the y value or the p value that correspond with that was 20. So I'm going to count up. And if you notice, I'm going by increments of 4 here. So I'm going to go up to where I see the 20, which is right about there. This is easier with graph paper, so just bear with me. But if you look out, it goes about to the 20 right there. Okay? So then the next point we had was 2, 8. So it was a side length of 2 and a perimeter of 8. So we're going to go 2 here and then up to 8 here. And make a little dot at that intersection. Then our next point was 7 and 28. So I'm going to go to 7 down here, pop up to 28. That gives me my next point. And my last point is 15, 60. I would love to graph that one, but we don't have room. So that's going to happen sometimes. If you don't have room, that's okay. Don't worry about graphing that one, okay? Just graph the ones that you have room for, okay? Now, if you notice, these points can actually be put together to form, that's not the straightest line ever, but they can be put together to form a line. And that is the type of relationship that we're looking at. So that's a good thing. We want it to look like it's a line because this is a linear relationship, which we haven't talked about a whole lot yet, but we'll get there. So it's a fun little vocabulary word for you guys. Okay, so let's go back and talk a little bit more about the tables. So let's erase this. We're gonna move back. Oh, that just fell. We're gonna move back to the tables. Okay, so let's say that we're given a table, okay, with a missing value, and we have to find the rule first before we can find the missing value, okay? So that's what we're gonna look at here. So if we've got a table, and then our variables are L and M, okay? And we are given 3 complete sets of data. So 5 and 20, 10 and 25, 15 and 30. Then we've got a 7 L value, and we're trying to find its corresponding M value. So in order to do this, we need to be able to identify the rule here. What is the relationship? What is the function? So let's talk about how we can figure this out. We can look at it and we can say, okay, so from 5 to 20, I know adding would be plus 15. We also just looked at multiplying, which our last rule was times 4. So that's a possibility. Let's see if that would work. 5 times 4 is 20, but let's kind of write that on here so you guys can see that a little better. So times 4. Okay, so if I multiply times 4 here though, I would have to multiply by 4 on all of them. So 10 times 4, that doesn't work. 10 times 4 is definitely not 25. So that means that multiplying by 4, even though it was the rule on the first group that we did, is not my rule here. So let's try something different. We already addressed the fact that we could add 15. So let's see if maybe that's our function here. So plus 15. Okay, that works. What about 10 plus 15? That does give me 25. So let's see if it keeps working. 15 plus 15, that does give me 30. So it's looking good. All right, so if it works on all the data that you have, you can go ahead and make that your rule, okay? So that means that my rule to find M is to add L plus 15, okay? That's gonna be my function or my rule. So therefore, if I want to find 7, I can just plug in a 7 here for L, and I know that 7 plus 15 is 22. So that means that my question mark right here is actually 22. Okay? So that's it for that one. Sometimes they will give you a table that already has the rule in it. So that's super helpful. Let's look at what that looks like when they give you a table that already has the rule. So this one is actually a horizontal table too. So same idea, it just looks like it's sideways, okay? Same concept. So it's just a long one, kind of, I guess, chubby one. I don't know how you would say that. So we've got X on top, 3X minus 2 on the bottom, okay? And then they give us 3 sets of data here. They tell us that we have 2, 3, 4 for our x values. And they give us 4 and 7, but then this is the one we're looking for over here. So they gave us the rule, so we don't have to look at it and figure out what the rule is. This right here, when they give us our other value or our other variable in terms of the first one, so you see how this has an x in it? That means they're giving us the rule. They're telling us, hey, if you know what x is, you can just plug it in right here, and then that'll tell you what your missing value is. So for this one, we just know that we are trying to find this value when x is 4. So I can take 3x minus 2, and I can replace that x with a 4. Now, be careful here, because notice what's happening with 3 and x. They are multiplying. Remember we say when they're squished together like that, that's multiplying, okay? There's no sign in between them, so that means they're multiplying. So when you plug in your 4, you have to make sure that you set it up as 3 times 4. Be very careful, okay? I always see mistakes on stuff like this. So 3 times 4 minus 2, okay? So now we want to simplify that. Now think order of operations. This is where somebody in class would say PEMDAS, and I would say high five, good job. So order of operations. Remember, we see multiplying happening and we see subtraction happening. Okay, which one comes first? We see multiplying is above subtraction, so we know that's going to happen first. So 3 times 4 is 12 minus 2. So then we subtract 12 minus 2 gives us 10. So your value that would get plugged in here would be a 10. And that's it. That's all I have for this lesson. So great job, guys, and happy homework.